I'm really excited to be with you all here today and share this unit with you. It's been a labor of love with lots of awesome people working on it, tried in lots of great classrooms, and it'll be really fun to see what you all do with it in the future. So if we go to the next slide, the high school scope and sequence, if we want to place ourselves in that right now, we're going to be in that middle column, which is the chemistry column, and then right toward the top where Sarah is pointing. So thermodynamics and earth systems is the very first unit of high school chemistry. And there's a lot of little text there and arrows, but we'll actually jump to the next slide so I can talk a little bit about that text. So this is some of the performance expectations that are bundled into this unit. So we intentionally chose these performance expectations together for reasons I'll explain momentarily. A couple of symbols you'll see here that you want to be aware of. If you see a little cross or dagger like there is next to HSPS C.1 at the top, that means that performance expectation is shared across courses, shared across units in different courses in the open-cited high school sequence. And then sometimes you'll see an asterisk or a star, which indicates that performance expectation is shared across units within the chemistry course. So to summarize these briefly, you'll notice there are two physical science performance expectations at the top there. The first relates to computationally modeling the change in energy of one component in a system if we know the change in energy of other components. So we're quantifying energy here and tracking it across a system. And then also another related to investigating to get evidence of thermal energy transfer, that actually results in the energy being more uniformly distributed throughout the system. In addition to that, there's some earth and space science performance expectations. The third one on the slide here relates to feedback loops in earth systems. And then the next one to variations in the flow of energy and how that relates to changes in climate in earth systems. We go to the next slide, Sarah. Then we see four more here that are earth and space science performance expectations related to coevolution of Earth systems and life on Earth, which is a cool idea. How availability of resources, natural hazards, and changes in climate influence human activity. We also dig into modeling climate over the long term to figure out what's going to happen with climate change, and connecting that to models of how Earth systems are modified due to human activity. And so one thing I just want to note here is there's a lot of Earth and space science ideas in this unit, and they're important scientific ideas in their own right. But in a chemistry course, it's really cool because they actually lead us to an anchoring phenomenon, which is going to provide a really meaningful context in which students can figure out important ideas about matter and energy. And also, it's noteworthy that as we think about climate change, which is what a lot of these earth and space science standards relate to, we can't explain that without actually understanding what's happening at the particle level. So we're moving from this huge global phenomenon to what's happening at some of the tiniest levels we deal with. If we go to the next slide, as we do this, I'll talk about this more later, but we try to be really intentional about picking certain science and engineering practices as well as cross-cutting concepts that we intentionally develop in the unit. So you can see here that those are asking questions and defining problems, planning and carrying out investigations, using math and computational thinking, as well as for cross-cutting concepts, systems and system models, and energy and matter.